In this video, I want to have a look at solving some harder inequalities. So we've talked about inequalities before and about the fact that the process for solving inequalities is the same as solving equations, except for that one difference, and that is that if you multiply or divide by a negative number, we have to flip the inequality sign. So let's jump into a few examples. The first one I want to have a look at is a double inequality. So we've got minus 2 is less than 3 outside of 2y minus 1 is less than 7. So I've got these two inequality signs. And all that means is that whatever we do to the middle, we also have to do to both sides of those inequalities. So if we expand this out first, and you don't have to, there's different ways you could work this out. We could do it without expanding it. So we've gone 3 times 2y gives us 6y, and 3 times minus 1 gives us minus 3. So now we're trying to get this y on its own in the middle, so let's add 3 to both sides. So minus 2 plus 3 would give us 1, is less than 6y, is less than 7 plus 3 would be 10. Then to get the y on its own, we're going to divide everything by 6. So we'd have 1/6 is less than y, is less than 10 over 6, which is the same thing as 1 and 2/3. So to sketch that, we'd have our number line. We've got 1/6, 1 and 2/3. Because that's a less than sign, not a less than or equal, they're going to be open circles at those two values. And it's between minus 1 and 1 and 2/3, so it's going to be this whole section in between that we're colouring in. All right, let's have a look at another example. So in this one, we've got 3 minus r over 2 is less than or equal to 6. So let's go through and solve. Let's get rid of the divided by 2, the bottom denominator of the fraction first. So we'll times both sides by 2. We'd have 3 minus r is less than or equal to 12. Then to get rid of this 3, because it's a positive 3, we'll subtract 3 from both sides. So we'll still be left with that minus r is less than or equal to 9. Now that minus in front is like a minus 1, so we've got to divide both sides by minus 1 to get that r on its own. So remember, if we divide or multiply by a negative number, it flips our inequality sign around. So now we've got r is greater than or equal to minus 9. So sketching that, we'd have our number line, got minus 9. Because it's greater than or equal to, it's going to be a coloured in dot, and then it's coming up this direction because it's greater than or equal to minus 9. In our last example, we've got two fractions. We've got x plus 1 over 2 minus x minus 2 over 3, and that's all greater than or equal to 7. So again, there's a couple of different ways you can approach this sort of question. Personally, I don't really like working with fractions, so I'm going to go through and get rid of them. So to get rid of this divided by 2, we're going to go through and multiply everything by 2. So we just have an x plus 1 here. We have minus 2 outside of x minus 2, and that's still all over 3. And we'd have that is greater than or equal to 14. Then to get rid of this 3 in the denominator here, we're going to multiply everything by 3. So we'll have 3 outside of x plus 1, minus 2 outside of x minus 2, is greater than or equal to 42. Now if we expand all this side out, we'd have 3x plus 3 minus 2x minus 2 times minus 2 will give us a plus 4, is greater than or equal to 42. Collect like terms, so 3x minus 2x will just leave us with x, and 3 plus 4 would give us 7, greater than or equal to 42. And then subtract 7 from both sides, so we'd have x is greater than or equal to 35. So we could have done that. I've done it in 2 steps. I got rid of the 2 and then the 3. So I multiplied everything by 2 and then I multiplied everything by 3. We could have done that all in one step if we just went through and multiplied everything by 6 as well. But it doesn't matter really, because either way will work. Then if we sketch our solution, we've got 35 here, and we've got x is greater than or equal to 35, so we'll colour that in. And then it's coming up this direction. Right, so those are a few examples of some harder inequalities.